Today in pre-cal we learned how to solve logarithmic equations. It's kind of the opposite of what we did yesterday. To solve logarithmic equations, we have two parts as usual. So part A is just how to solve. To do that we want to write it in exponential form. So let's just practice a few problems. Example number 1. If I do log base 3 of 5x minus 1 equals log base 3 of x plus 7. Okay, when I look at this, I notice that both of them are base 3. They're both by themselves. To get rid of log base 3, what I want to do is raise both by the power of 3. So now these 3's, what I do to one side, I do to the other. It's the inverse. Since these are inverses, this part cancels. Notice this stuff right here is all your exponent of 3. Those have canceled now, and I have 5x minus 1 equals x plus 7. Now it's just a simple algebra problem. I move my x's over to one side and my numbers to the other. I'm kind of following both processes at once. So if you wanted to do that in more than one step, you could. And finally, I'll see that x equals 2. Okay, my end goal is to get x by itself. Let's look at another example. Log base 6 of 3x plus 14 minus log base 6 of 5 is equal to log base 6 of 2x. In this problem, I have two logs on the same side, which I will need to condense using my properties of logs before I can move on. I notice that they're being subtracted, so to condense, I can divide the argument. So it's going to be this over this, all log base 6. So log base 6 of 3x plus 14 over 5 equals log base 6 of 2x. I raise both by using a base of 6. Let those cancel. And I have 3x plus 14 over 5 equals 2x. Now I just need to solve. So I'm going to multiply by 5 on both sides. 3x plus 14 equals 10x. Subtract 3x from both sides. 14 equals 7x. Divide by 7, and x equals to 2. Now, it's a coincidence that both are covered, so that's not a big deal there. Okay, the next thing we want to look at, example number 3, is one dealing with natural log, and one where the log is only on one side. So if I'm looking at the natural log of 3, only a log on this side, not on this side, I still use that this one has a base of e and raise it by the power of e. So e and ln will cancel. On this side I have x. On the other side I have e to the third power, which when I put in my calculator is about 20.086. And that's all there is to that. Let's look at some more where there's just a log on one side. So I have 5 plus 2 natural log of x equals 4. I want to get x by itself. First I've got to undo some of this stuff. Be sure you're using the order of operations. You cannot add these before you start subtracting and dividing. So I'm going to subtract by 5 on both sides. 2 natural log of x equals negative 1. Divide by 2. Natural log of x equals negative 1/2. Raise both by the power of e. And x equals e to the negative 1/2. And if I put that in my calculator, I get 0.607. Okay. Let me do one more where there's something more to the argument. Example 5, 2 log base 5 of 3x equals 4. Okay, I'm going to divide by 2 first so I can get the log by itself. I have log base 5 of 3x equals 2. To get rid of log base 5, I'm going to raise it by the power of 5. Now on this side I'm going to have 3x. On the other side I have 5 squared, which is 25. And so if I divide both by 3, I'll get my answer, which is x equals 8.333. And I could have left it as a fraction 25 over 3, but I didn't in this case. The last thing we need to talk about, part B, is how to check for extraneous or extra solutions. And I'm abbreviating here. The reason we have to do that is you need to recall that we cannot take the log of a negative number. So in the interest of that, if we come up with a negative solution, we have to check it. This will be like the second half of your homework today. We'll start with just a problem. So example 6, log of 5x plus log of x minus 1 equals 2. Okay, my logs share the same base, so I can put them together using my rules, my properties. They're being added so I can multiply. Now I know that the base is 10 because there isn't one written in, and so when that happens, my base is 10. I'm going to raise both by that power. On that side, it'll cancel. And at the same time, I'm going to distribute this just to make it easier. I could make that another step if I needed to, but 5x times x is 5x squared. 5x times negative 1 is negative 5x. On the other side, I'm doing 10 squared, which is 100. Now I want to move everything to one side so I can solve. So I will subtract 100. And so I have 5x squared minus 5x minus 100 equals 0. I have to factor that to get some solutions for x. Out from everything, I can pull a 5. That one just stays on the outside. Then I can factor this trinomial by saying what multiplies to get negative 20 and what adds to get negative 1. And that would be negative 1 and positive 4. So my two solutions are x equals 5 and x equals negative 4. Now, notice for the first time we have a solution that's negative. This is why we have to check. To check, you're going to plug in each solution. And we're going to plug that into our original equation. So I'm going to start by checking x equals 5 because it was my first solution. And I'm going to do log of 5 times 5 because that's our x, plus log of 5 minus 1 equals 2. And I'm going to get log of 25 plus log of 4 equals 2. Now, because this one is log base 10, I could put this in my calculator. I could also use my properties and combine. Since they're being added, I could multiply. 25 times 4 is 100. So log base 10 of 100 is 2. That should make sense to you because 10 squared is indeed 100. Or you could put this in your calculator. The reason I was going over that with you is so that if you wanted to double check and the base was not one in your calculator, you could still do that. The main point here, guys, is that we're not trying to take the log of a negative, so we know that this solution will work. Let's try the other solution of negative 4. Log of 5 times negative 4 plus log of negative 4 minus 1 equals 2. This one would be log of negative 20 plus log of negative 5 equals 2. And I can't take the log of a negative number. So this part is out and it's no solution there. So my final solution is x equals 5. The last thing I want to point out before you get started on this assignment is that in your homework there is a problem where you work it all down and it's one negative solution. So it'd be like if we just got this and it didn't work. If that happens, the total answer is no solution. So again, the reason we're checking is because there's a negative here. You might also be asking yourself, well, what if I multiplied this out? Negative 20 and negative 5. That would make positive 100, which would work again. However, before that happens, we cannot take the log of a negative number, which is why we plug into the original to check. The assignment here is A8. It's page 254. It's number 76 to 88 even, and that's like section A of your notes. And then 96 to 100 even, and that's like section B of your notes. Good luck, and if you have any questions, let me know. I'm happy to help.